Nodal analysis. Let's analyze the following circuit with the nodal analysis. First of all, what is nodal method or nodal voltage method? Nodal analysis is the application of the Kirchhoff's current law. If you remember, the Kirchhoff's current law states that the sum of all currents coming into the node equals to the sum of all currents leaving the node or going out from the node. So that's the equation. But the next question is what actually node means. The node is the point where two or more branches are connected. On our diagram we can easily see two nodes. So let's name them. The first will be node 1 and the second node will be node 2. Next, let's assign the main voltages we'll be working with. The first is the reference node, shown by this symbol. Usually we put the reference node somewhere at the bottom of the circuit, and at the reference node the voltage will be 0. And also we'll be using another two voltages, V1 and V2, which we call node voltage. So at the end, applying Kirchhoff's current law to each node, we're supposed to produce two equations, and as the result of solving these equations, we'll be able to find nodal voltage V1 and nodal voltage V2. To be able to apply KCL to each node, we need to know the direction of each current. So let's have a look where the current will flow in each branch. We'll start with 10 volts power source. We know that the current is leaving the positive terminal, so it will follow by the direction on this branch. The current will be going into node V1. On the other side, on the right, we can see the current source as 2 amps. This is already current source, which means we already know the direction of that current, and followed by this direction the current is going into node V2. Now the vertical branches, because at the bottom we have the voltage, the potential is 0, so it's obviously below potential, and the high potential or positive will be at the top at voltages V1 and V2. You know that the current flows from high potential to low potential in the resistor, so the direction of the current in these branches will be downwards. On the diagram we can see that there is only one current left. This is the current between V1 and V2. Actually, it's probably hard to say exactly if the current will be going to the right or to the left. So sometimes in nodal analysis you need to guess. But the most important is to be consistent and to use the direction of the current you choose. So let's assume for this example that the current goes from V1 to V2, so to the right. Now we have all the currents ready, but in terms of finding voltages V1 and V2, we need to express each current using Ohm's law. How to do this? So the current flowing through the resistor equals the voltage at high potential minus voltage at low potential. Easy to say, voltage at plus minus voltage at minus divided by the value of resistor over R. Let's check 1 ohm resistor. We know that the current in the resistor flows again from high potential to low potential, in other words from plus to minus. So we can put plus and minus, and let's call this current as I1. So what would be the current I1, the current flowing through 1 ohm resistor? Using this formula, the current I1 will be voltage at plus. So let's check what voltage we have at plus, and that is 10 volts. So we put 10 minus voltage at minus. Looking on the diagram, voltage at minus is V1. So 10 minus V1 over, and the resistance is 1 over 1 ohm. Following by the same method, we can identify the current in each branch. To make it easier and do not do a mistake, let's assign the polarities across each resistor. So for 1 ohm resistor, as we already said, that's going to be plus and minus, so the current flows from high to low potential. Then going to 5 ohm resistor, just put plus and minus. 2 ohms, plus minus, according to the direction of the current. 10 ohms, plus minus, and 2 amps is the current already known. So before we start writing the total equation for each node, let's practice one more time and write the value of the current, let's call it I2, the current between V1 and V2. So from the Ohm's law, current I2 will be voltage at plus. So what voltage do we have at plus? And it is V1, so we put V1, minus voltage at minus, and at minus we have voltage V2, minus V2 over resistance, and it is 2 ohms, over 2. Now, applying KCL to each node and expressing each current through V1 and V2, we can write nodal equations. We have 2 nodes, so we need to write 2 equations. Let's start with node 1. So write the equation at node 1. To make it easier and consistent, let's assume that the currents coming into the node will be positive and the currents leaving the node will be negative. So the first current, I1, or the current through 1 ohm resistor, it's going into node V1, so that current will be positive. So what should we write? The current I1 equals to voltage at plus is 10, minus voltage at minus is V1 over resistance over 1. Then let's look on the current going through 5 ohm resistor. It's going down out from the node, so we assign this as negative current, so we put minus. And same method, voltage at plus will be for this current V1 minus voltage at minus, and at the bottom we have reference node where voltage is 0, so minus 0 over resistance over 5. If you look into the node V1, we can see that there are 3 currents at this node, so we should have 3 components in the equation. The last one is current, in our diagram is shown as I2, the current through 2 ohms resistor. It's going out from the node, so you put minus, and again voltage at plus is V1, minus voltage at minus is V2 over 2 ohms, and everything equals to 0. Now let's write a nodal equation for node 2. So use a different color, node 2. And again we have 3 currents, so we should have 3 components in the equation. The first current I2 now is coming into the node, so we make it positive, which will be voltage at plus V1 minus voltage at minus V2 over resistance over 2. Then the current through 10 ohms resistor is leaving the node, going out, so that will be negative. Minus, for this current, voltage at plus is V2 minus voltage at minus, and it is reference node where voltage is 0, so minus 0 over resistance over 10. And we also have one more current coming in, and this is 2 amps. So this current already known, and it is coming in, so it will be positive, so you put plus 2. And that will be your second nodal equation. Basically, just now we produced the most important part in nodal analysis. We generate 2 nodal equations. Now let's see if we can solve it. We have 2 equations and we have 2 unknowns, V1 and V2. If the number of unknowns equals to the number of equations, we can solve it. I'm going to skip the solving process, but I certainly encourage you to try to solve 2 equations, 2 simultaneous equations. If you're still unsure, the full solution is shown on the lecture 3 notes, so always welcome to go through the lecture notes and check if you're everything doing right. But at the end, we're trying to find nodal voltages V1 and V2. So solving two equations, we'll get that V1 equals to 9.09 volts and V2 is 10.9 volts. But why do we need to know nodal voltages? Well, by knowing nodal voltages, we can find any current in any branch. For example, what would be the current I1? And we know that I1 is 10 minus V1 over 1. And because we already found nodal voltage V1, we can find the current I1, which will be 10 minus 9.09 over 1, which equals to 0.91 amps. And we can do exactly the same thing for any current. Just one more example. For example, you need to find current I2. And again, we already identified that the current I2 is voltage at plus V1 minus voltage at minus V2 over 2. And we already know V1 and V2, so just substitute the numbers into the equation, we'll get current I2, which will be V1 is 9.09 minus V2 10.9 over 2. And we can see that the current I2 is negative 0.905 amps. What does it mean? You don't have to worry that your answer is negative. This only means that the actual current I2 is flowing to the opposite direction. So if you remember, I advise you that sometimes you need to guess the direction of the current. So basically your solution will show if you propose the right direction or wrong. But it is fine. So you have negative current, and you can say that the current I2 goes from node V2 to node V1. And once we know the value of each current, we know resistance, we can find the voltage across each resistor or the power delivered or dissipated by any resistor in the circuit.